questions are not correct. Okay, now exercise 6.1. Could I just do a check? Are we ready to start? Can I get everyone's attention, please? Ready? Okay, exercise 6.1. Any problems with question 5? Question 10? 11? 11, okay. How about question 12? Question 12, okay. Then exercise 6.2. Any issues with question 7? 7, 11, 15. How about 19? For exercise 6.1. Could I just understand whether for question 11, is there a problem with part 1 or is it just part 2? Part 2, huh? Okay, then I'll jump into part 2, yeah? Okay. Part 1, the answer should be this. Then for part 2, they want you to hence expand 1 plus x, minus 2x squared to the power of 6 up to the term in x cubed. Okay, so in order to answer this question, to make use of your answer in part I, we will let x in part I be x minus 2x. Okay, is that correct? Correct, we let x in part I to become x minus 2x. 2x squared. Is that all? Should be negative, right? Because take note down here is a negative. Okay? So therefore, if you want to change this into a negative, it should be 1 minus x plus 2x squared. Okay? Then they are comparable forms. Okay? So therefore, you should use negative x plus 2x squared, okay, for your substitution. Then now, we will have 1 minus 6 negative x plus 2x squared plus 15 negative x plus 2x squared minus 20 bracket negative x plus 2x squared. Okay, so we have this. Alright, then since we're trying to expand up to x cubed only, okay, you just have to keep all the terms up to x cubed. The ones that are more, you can just hide it inside the dot. Okay, so in this first one, you will get plus 6x minus 12x squared. Okay, you can expand by brute force. That means you use the formula a squared plus 2ab plus b squared. Okay. For the one in cube, so we will have one of each put out. The other one will be the negative x plus 2x squared, which is the same as this, so I'm going to copy this. Okay, and then x squared minus 4x cubed plus 4x power 4 minus 20. Am I right so far? 1 plus 6x minus 12x squared. Okay? Then since we are going to expand up to x cubed, then let's only take out the things that are x cubed related. Okay? For this one, all I need is 15 with x squared and 15 with negative 4x cubed. 15 times 2, 30, 60 x cubed. Okay, I'm not going to take this since it's not going to be, it will go exceed the x cube. Then over here, I will strategize a little. Let me just expand this one. Minus. Plus 20x minus 4x. For this part here, I expanded it already. Then I will now take this, multiply with this, and nothing more. Okay? For the one that is cubed, only this and this is helpful. Other than that, nothing else will give me everything else will give me more than x cubed already. Okay, so that will give me 20 x cubed plus blah blah blah. So I check, yep. Okay, so we'll get this. Check your own answers. Okay. Next we look at exercise 6.2. Question 12. Not exercise 6.2, but question 12. Okay, we want to expand 1 minus x times 1 plus ax to the power of 6 as far as the term in x squared. Okay, and it says that the result is going to be 1 plus bx squared. So upon simplification, we get this. I'm just writing down the information in the textbook. Okay, question wants us to find the value of a and b. Okay, so what we'll do is to also strategize how we go about expanding. Okay, so because we have up to power of 6 here, if I expand it, right, I'll expand it ascending orders of x. Okay, so just look at this expansion first. Using our formula, okay, 1 to the power of 6 plus 6 choose 1, 1 to the power of 5, ax to the power of 1, plus 6 choose 2, 1 to the power of 4, ax to the power of 4. Okay, we only need to expand up to here for this one, okay, because you're trying to expand this whole thing up to x squared. So I will need my 1 to multiply with an x squared term and my x to multiply with an x term, okay, in order for me to expand up to x squared. If I expand up to another x cubed, for example, okay, that will be too much already. It will surely exceed. So expanding up to here will be the best already. So we simplify. plus 6ax plus 15a square x square. Okay, then now we can proceed. Okay, then we do our rainbow. Can I erase the purple ones already? Enough? Okay, so what we'll do is 1 times 1, 1 times 6ax, then 1 times 15a square x square. Okay, then followed by negative x times 1, negative 6a x squared, negative 15a square x cubed. But this x cubed, we actually don't need it, so it's fine if you actually drop it. Okay. Then we go about simplifying all the like terms. That means the terms with the x. Factorize out the x, I write it in this manner. I do the same for the x squared term. Okay. Then because the question actually mentioned that this simplifies to 1 plus bx squared, okay, upon expansion, that means that my 1 maintains, my bx squared is supposed to represent this. Okay, notice that in the simplification, there is no term that is x to the power of 1. Okay, so that will mean that your 6a minus 1 must be equals to 0. Because if it were to be something that's non-zero, then surely it must be inside my simplified form. Okay, so therefore, okay, by comparison, 6a minus 1 is 0, and then 15a squared minus 6a equals to b. Okay, so 6a minus 1 equals to 0 means a is equals to 1 over 6. I substitute all the a here with 1 over 6 to find that my value of b will have to be negative 7 over 12. Okay. Questions? Okay, next we look at exercise 6.2. Question 7. Okay, it has shown you already what is the binomial expansion of px minus 3 to the power of n. It mentioned that the expansion goes to 5, 1, 2x power 9 minus qx power 8 and then plus dot dot dot. Okay, when arranged in descending powers. Okay, what we need to do in this case is the same logic that we did in question 12 earlier. Okay, we go about expanding px minus 3 to the power of n first. Okay. px to the power of n with brackets, n choose 1, px bracket power n minus 1 and then negative 3. Okay? Because the question only told us that the simplification upon expansion only gives us the first two terms, that's why I only expand up to the first two terms. Okay? Then because this one the power is 9, so we can conclude that n must actually be 9. So if you want to, you can write down by comparison. Px bracket power n will be 512 x power 9. So n equals to 9. Okay, and p to the power of 9 equals to 512. Okay, so therefore p must be the 9th root of 512. 9th root will be 512 to the power of 1 over 9. That will be equals to 2. Okay. So now we have figured out what is n already and what is p. We can next figure out what is q. So likewise by comparison, negative q x power 8 equals to n choose 1 px to the power n minus 1 times negative 3. N choose 1 is n. P I already know it is 2x. N I know that it is 9. So this one is 9. 9 minus 1 negative 3. So 9 times 2 to the power of 8 times negative 3. That will give us negative 6912 x to the power of 8. Therefore, q will be 6912. Questions? Right? Okay, hope that those that ask for these questions to be gone through, you are looking at it. If you have any further questions while doing the steps, please do clarify as well. Okay? Don't just be concerned about copying the answers. Question 15, is the issue with part I whole question or which part? Who has issue with 15 part I? 15 part I, okay, part I also already have issue, then we go through whole question. Okay? Okay, we want to find the term in x to the power of 10. This question requires us to use our general term formula. N minus R. Okay, that's the general term formula. So apply that to this. simplifying this. Okay, 10 choose r, we keep it as such. Then the x cubed, okay, we can write it as x to the power 30 minus 3r. The challenge comes in for the negative 2 over x squared to the power of r. Okay, to help you break it down, I want you to see it as negative 2 to the power of r. Okay, maybe not break it down like that first. I want you to see it as negative 2 times 1 over x squared to the power of r. Okay, then okay, by our indices law, we can have negative 2 to the power of r and 1 over x squared to the power of r. 1 over x squared is x to the power negative 2. So I write it like that. In fact, the r can be brought in and left as this. Okay? So I have my numerical basis, the negative 2 over here. We will put that with my coefficient related things. And then the variables, my bases are x, power-wise will become 30 minus 3r minus 2r, so minus 5r. Okay? You need to simplify it to this extent first before you can proceed to actually solve the question. Alright? So, the term in x to the power of 10 would mean that 30 minus 5r equals to 10. So r is equals to 4. Okay? So therefore, the term that we're looking to find is the fifth term. Minus away 5 times 4. And that will give us 3360 x to the power of 10. Okay? Coefficient of 1 over x to the power of 5. Okay, so what should I use, okay, for my power over here to substitute into the 30 minus 5r? We have 1 over x to the power of 5. Okay, what should I substitute for the 30 minus 5r? Singing, what do you think? Sorry, now the position changed. I don't know who is singing anymore. Who is singing? Yes. So you can tell me what do we use to change for the 30 minus 5r? You understand my question? Do you understand my question? My question is, because you're trying to find the coefficient of 1 over x power 5, the term you is having this. General term is this one already. Okay, so x to the power of 30 minus 5r, okay, is where the variable is. So 30 minus 5r, need to substitute with a certain number so that I can find r. Okay, just like in part I, because my power is 10, I substitute 30 minus 5r to be 10. So in part 2, what do I substitute for my 30 minus 5r? Negative 5. Is it? Okay, yes. So you need to recognize that this refers to x to the power negative 5. So substitute like that. So we find that r is equals to 7. Okay? I only want to find the coefficient. That will mean that I'm only looking for this part. So I only need to have 10 through 7 times negative 2 to the power of 7. That will leave us with negative 15,360. To find the constant term, what does constant term implies? My power of x must be equals to what? 0. So therefore 30 minus 5r must be equals to 0. Okay, I leave it to you to solve. I think this one shouldn't be a problem. Okay, because part I, part 2 have done it already. Your constant term answer should be 13,440. Okay? Question 19, shall we? Okay, can I erase this side? Not yet. Okay. Can I erase this side already? Can the two digits, this one okay to erase? Sorry, now it's just convenient already. Question 19. Okay, question 19, could I just clarify, is part I an issue? Question 19, part I is an issue? Okay, okay. So this one, they told you that the constant term is 7 already. By similar idea, we have to find the general term to make things simpler. Otherwise, you will expand until no tomorrow. Okay? So, PR plus 1, A choose R, A is X, N is A minus R, B is negative K X cubed to the power of R. Okay? So actually it's the same challenge as your previous question, as your question 15, with regards to this one. Okay? If you understand what I did earlier on, you should be able to break it down as negative K to the power of R times X to the power negative 3 to the power of R. Okay? If you still don't get it, I want you to see that this is the same as negative K times 1 over X cubed. Okay, then we proceed with putting it into coefficient and variable form. caution, okay, but now I want to caution. This power r over here, take note that it must be outside the brackets, cannot be inside the brackets. Okay, negative k to the power of r is not the same as negative k to the power of r like that. Okay, because this r has an effect on the negative. This is negative 1 times k. Okay, so do take note of how you write this. R must be outside the brackets. Earlier on in question 15, we also had our negative 2 to the power of r. Power also on the outside. Okay, so do check your homework. Okay, since we're looking for the constant term, 8 minus 4r, as you all pointed out earlier already, power of x must be equals to 0. So 4r equals to 8, r is equals to 2. Okay, so now we can find the constant term, which will be 8 choose 2, negative k to the power of 2. This one itself naturally should become 0. So 8 choose 2 is 28. Negative 2 bracket square will actually be k square. Negative square becomes positive. Okay, so 28 k square is equals to 7 as given in the question. So k square equals to 7 over 28, that is 1 over 4. K equals to half or negative half. Remember, when we take square root, we need to have both positive and negative. Okay, but question say k is more than 0, so you reject negative half. Okay, while we are going to reject negative half, it is still important that you have the practice of writing the negative square root, and then you state out clearly the rejection. Okay. So that is for part I. Okay, now part 2, I'm sure this is the one that most of you would know. Even if you know how to do, okay, I want you to make sure you know how to write out your answer. Okay, part 2 asks, using the value of k that we found, which is half, explain why there is no constant term in the expansion of 1 plus x power 4 times x minus k over x cubed to the power of 8. Okay, so let's really understand the question first, yeah? Okay, where does this question come from? Or as in, where does it stem from? Okay, right, so earlier on in part I, we recognize that there is a constant term in part I, and if we think about the whole expansion procedure, your rainbow method, right? If down here has a constant term which is 7, okay, 1 times 7, it does give me 7. So it seems like there is a possibility of having a constant term, right? Okay, but then the thing is, why the question still asks, why is there no constant term? Okay, so we need to go and dive deeper to understand, okay, this expansion already. We know 1 times 7 can give me something, okay? But I also know that in order to have the full constant term for this expansion, my x to the power of 4 must multiply by something over here, okay, to give me another constant term as well, okay? So x to the power of 4 needs to multiply with a term that has 1 over x to the power of 4, okay, some number times 1 over x power 4 in order to give me a constant term. So this will expand or will multiply with 7. X to the power 4 will multiply with a term that is 1 over x to the power 4. Okay? I know the 7 already, but I need to go and find out what is this thing. Okay? So let's proceed with that. Okay, so in part I, we already had a general term. So let's look at the power when it is equals to negative 4. Because we are in search of our term of 1 over x to the power of 4. Okay? So x will have the power negative 4. Alright? So that means that my 4r equals to 8 plus 4, that's 12. R equals to 3. So it seems like that term exists. Okay? That there is such a term that has 1 over x to the power of 4. Okay? Then now, let's really go and find out the actual term itself. That will be the fourth term. 8 choose R, which is 3. K, we are looking at half. Okay? Power 3, x to the power of negative 4 actually. Okay? So 8 choose 3 will actually give us what? 8 choose 3, 56. Negative 1 over 8, x to the power of negative 4. Okay? This gives us negative 7, x to the power negative 4. Okay? So we see that our x to the power of 4 is going to multiply with a negative 7 x to the power negative 4 or negative 7 over x to the power 4. Okay? So just a very loose idea first. X to the power 4 multiply with this. What does it generate? It generates a negative 7. Okay? When this multiply with this. 1 times 7 gives us a 7. Add them up together, we get 0. Okay? So just a very loose idea first. Okay, let me frame it all up. Okay, as a nicer presentation. Right, so we say that, can I erase this part so that I got space to write? Erase this part, over here is to explain why was it that we were looking for this x to the power negative 4 term. Okay, so you need to verbalize it out, okay, to write it out as part of your explanation. Okay, then from this working, we can also now proceed to find out what is the constant term. Then we proceed with that working, where we know that we have to take 1 times 7 plus x to the power of 4 times negative 7x to the power of negative 4. So this is 7. This will give us negative 7. It gives us a 0. Okay? Therefore, there is no constant term. In the expansion. We left 10 minutes for our lesson. Now I have not appointed a maths rep for our class, correct? Okay, I think I need a maths rep, okay, regarding my homework matters. Since Cheyenne has been very kindly helping me to set up the camera, shall I give you 一个名分 that you shall be my maths rep? But okay, okay, anybody want to then be a maths rep? Ming San, you okay with it? Sure. It's very simple task one. Okay, I'm not expecting a lot today from a maths rep. Okay. Since I only got 10 minutes left, I want to do one question. Okay, for the circles SLS, so that I can really finish out that part of the SLS. Okay, that I promised you to do. Then after that, the homework, right? Okay, would I trouble you to all submit to Ming San? Okay, Ming San put inside my locker, number 43. Okay, by the end of today. Don't do it now, do it later lah. Okay, number 43. Okay. Okay, I want to look at this last question that I gave in your SLS. Okay, because I was looking at your answers and I think some of you are not understanding the point of the lesson. Okay, this question did not give you any diagram. It will be helpful to actually draw out a diagram if you like to imagine the question. So it says a circle passes through 1, 6 and negative 5, negative 2, such that AB is a diameter. So just draw anything. Your diagram need not be accurate, although sometimes it will be helpful to have it accurately drawn. Okay, in the sense that the position makes sense. Okay, but let me just maybe have my B over here and my 6 to be somewhat here. Sorry, my A should be somewhat here. Okay, it is a diameter, that means it passes through the center. Okay, we want to find the coordinates of the center of the circle. Let the center be C. Okay, because we are given the coordinates of A and B, C being the center, the midpoint in fact of the diameter. We have learned a midpoint formula last year already. Okay, I think that's in your chapter 6, if I'm not, chapter 7 if I'm not wrong. Okay, so midpoint formula will tell us that we take the x coordinate, add them up, divide by 2. Likewise, y coordinate, add them up, divide by 2. Okay, and then we will get that the coordinates of C will be negative 2, 2. Okay, so I think there were a few of you whose center coordinates was not correct. Okay. Then for part 2, we want to find the equation of the circle in standard form. Now, equation of a circle in standard form, right, goes by this so-called formula. Okay, so x and y itself, okay, must be present. It is the variable. Just like how our usual equation for straight line is y equals to mx plus c. X and y are there. M and c are things we need to find. So in this case, A and B is the coordinates of center. And then R is actually the radius. Not forgetting to square it. Okay? I have one person, okay, who gave me the answer. I forgot, is it Joshua or Josh, or maybe it's someone else. Okay? You give me your answer, maybe something like that. Okay? Now, this is not the equation of a circle. How come got double y? Okay? The equation must be this entire thing. Okay? I really don't know whether is it Josh or Joshua. Just have this memory that somebody did this. Okay? That it belongs to one of the Joshes in our class. Okay? So, but if it's not, then I'm sorry. Okay? But this one like that is not correct. Okay? Now, how to go about finding the coordinates of the center? We already have it. The challenge is to find out what is the radius. Since I know that AB forms the diameter, I can find out what is the radius. Okay, so the diameter, using our length of line segment formula, I will have 1 minus negative 5 square plus 6 minus negative 2 square. This one we learned in E-maths, length of line segment. Okay? And that would give us 10 as our answer. But we don't want the diameter, we want the radius. This was the part where I went wrong in the answer that I gave you in the SLS. Okay, radius should be 5. Therefore, the equation will be x minus negative 2 square plus y minus 2 square equals to 5 square. We must simplify this. We get x plus 2 square plus y minus 2 square equals to 25. Okay, so this will be the equation of the circle, which most of you are able to get, but there's also another significant part of this class that didn't get the correct answer. Okay, I didn't quite understand how some of you got the R value because your natural working, I don't know how some of you this value is not correct. Okay, some people give like 36 or some weird non-perfect square number. Okay. Then last one, part 3. Okay, determine if D24 lies outside, inside, or on the circle. So we cannot just base on the image itself to know. We need to compare the radius, the distance. Okay, so let's say if my D was to be maybe around here. Okay, I can go and find out what is this distance over here. If my distance from C to D is longer than the radius, then surely it is outside the circle. If it is lesser than the radius, then it will be inside the circle. If it is equal to radius, then it must be on the circle. Okay? So part 3, find out the length of CD, and that will actually be using length of line segment formula again. Okay, we get about 4.4721. That is lesser than 5. To specify it, that is lesser than 5. So it is lesser than the radius, hence D lies inside the circle. Okay. The question asks for whether is it inside, outside, or on. I don't know why. Got people in this class give me yes and no as answer. I don't know what does it even mean. Okay. Yes what, no what. Answer the question please. Oh. Okay. Okay. So tomorrow we'll continue with our circles, alright? Then just to clarify this point, AMS is supposed to be here. Chapter 6 in 12.1. Okay. One more thing. Practice papers for your WA1. I think some of you, before your card asked me, I already did it. It's already on Google Classroom. Okay, I already placed it on Google Classroom itself. For both last year is 2022 and 2021 because they were both of relevant topics. Okay, so you can go and try it yourself. I will not be printing it out. I think since we have Google Classroom already, you can do it digitally. But if you like to have a hard copy instead, you can always just let me know. I don't mind just printing one or two for some of you. Okay? Alright, that's all. Thank you everyone.